Hello viewers, welcome back to my channel Learn with Ravi. In my previous video of C language, I began the content flow, and in this video, let us see the introduction of the basic concepts. So let's get started. So let us speak about the basic terminology of computer science. So where shall we start? We shall start with the word computer. What is a computer? You have been using machines in your real life. You cannot think of your life without a mobile in your hand, isn't it? Similarly, a computer is also a machine. Now, what kind of machine is that? It is a programmable machine which is designed to process your data based on the instructions written in a program. A computer is a programmable machine that can perform operations based on the instructions written in a program. Now, the basic important word of the computer, that is data. What is data? People say I have got a lot of data with me. So data can be group of bits and bytes, data can be images, data can be text, data can be videos, data can be anything. So basically we define the word data as it is the collection of raw entities. For example, satellite sends the data of weather and you need someone to process it. So data is basically collection of raw entities, and data may make sense, data may not make sense. Now define the word information. What is information? Information is basically the processed data, and obviously information will make sense when compared to data. So data may or may not make sense, whereas information will make sense. So that is the difference between data and information. Clear with that? Let us learn the word instruction. What is an instruction? It can be a single word or it can be a statement written to a machine to perform a task. So instruction is a predefined statement or word written to make the machine perform a task. Fine with that? Now going ahead, let us learn about the word program. And a program is a set of ordered instructions. Now what do you mean by the word ordered instructions? When you have set of instructions, you need to arrange them in a particular sequence so that you get the output in the required fashion. So keep in mind, a program is set of ordered instructions. Let us learn what is hardware, what is software. Now what is hardware? Any physical component that you can touch and feel is hardware. Now the examples will be mouse, yes, the keyboard, the monitor, whatever it is. So all these are called as hardware. When you open the CPU, you have some components inside, right? You have hard disk, you have SMPS, you have motherboard. All these can be called as hardware. So basically, hardware can be defined as a physical component of a machine. Now going ahead, what is software? A software is collection of programs meant for performing some operations. We have seen the word instruction. An instruction is a predefined statement to make the machine perform a task, and set of those instructions put together is called a program, and set of those programs is called as software. So set of interrelated programs put together to perform an operation is a software. Now we have different types of softwares. First one is system software, second one is application software. So keep in mind, softwares can be classified into two categories. First one is system software, second one is application software. So let us see what is system software. As the name says, system software, a software designed for system functionality. So it is a program or group of programs put together to make the system work according to its make and wear. So the name says system software. Software designed for system functionality is called as system software. Now what are the examples of system software? The very first example we speak about is the operating systems what we use. You cannot use a machine without its software. Like to use a laptop, you need an OS. That OS will be either Windows, it can be a Mac OS, it can be Tizen. If you are using a mobile, it is Android or iOS, whatever you call it as. So Windows, Android, Linux, Ubuntu are all the examples of the operating system, and operating system is the first example of system software. It makes the system respond according to the user instructions. Now we have second example. The second example is called as language translators. In a couple of seconds we will see types of languages, but for now the name says language translators, which are also the examples of system softwares, and they are compilers, interpreters, assemblers. So this is the second example of system softwares. Next we have the very important word called as device drivers. Device drivers are also system softwares. What do you mean by the word device driver? For example, if you plug in an external IO device to your laptop or your desktop, to make that external device work, you need to have a software that can identify that device to your OS. So your OS needs a software that can identify that external device. For example, when you connect a printer to your laptop, to make the printer work, then you need to install the printer software in your laptop. So that printer software is called as device driver. Similarly, any IO device you plug into your machine should have device drivers. Only when the device drivers are present, the machine or the OS will identify that device. So device driver is also the example of system software. Fine with that? Next, we have the concepts of linkers and loaders, which are also system software. So if anybody questions you what is system software, make it simple and straight. A software designed for system functionality is system software. The examples are operating systems, language translators, and then device drivers, then linkers and loaders. Fine with that? These are all the examples of system softwares. Now going ahead, what is an application software? As the name says, application software. It is a program or group of programs designed for end users to make their task function properly, and we call applications in short as app. For example, you'll be using MS Office, right? MS Office contains word processor, it contains spreadsheets, it contains all the required things for the accounting applications. So that is a application software. Example 2, you have a web browser where you open in many websites to search or to do many things. So web browser is an application software. An animal client can be thought of an app, and a media player, a file viewer, simulators, console games, photo editors, all these can be called as application softwares. If you open your Google Play Store or Apple Store in your mobiles, there are plenty of apps, and all these apps have got a specific functionality, so we can call them as application softwares. Keep them in mind, most of them are application softwares. Fine with that? So system softwares are softwares designed for system functionality. Application softwares are the softwares designed for the end users. Fine with that? So going ahead, now define the word programming language. What is language? You generally talk English. You normally talk English. You talk Telugu. You talk Spanish. You talk Italian, or whatever it is. Why do you talk, or how do you talk? You use a language to communicate so that you can express your thoughts and views. Now, what do you mean by the word programming language? The very name says a programming language is a vocabulary with a set of grammatical rules meant for instructing a machine to perform specific tasks. Now, whenever you talk English based on some set of rules. You cannot talk English according to your mind. We speak by following some set of grammar rules. Similarly, when you want to make the machine work according to your instructions, you need some tool of communication to make that machine work, and that mode of communication is generally a programming language. So programming language is a vocabulary with set of grammar rules. Fine with that? Now, what are the different types of programming languages? They are low level language and high level language. We have only two types of programming languages. First one is a low level language, second one is a high level language. We have different factors to classify programming languages, but one such functionality is low level language and high level language. So a low level language can be thought of into two categories. First one is machine language, other one is assembly language. So machine language, assembly language are types of low level language, and we'll see high level language in detail. So low level again has two categories, machine level and assembly level. Is that fine with you? Now going ahead, the diagram makes sense. See, on the base you have hardware. To communicate with the hardware you need a machine language, and to that machine language has upper layer called as assembly language, and that assembly language has a layer called as high level language. And we use C, Fortran, C, Pascal, CPP, Java. All these are high level languages, and all these high level languages are generally written in user understandable language, generally English. right? But a machine do not know English or Spanish, right? Then you need to convert that high level language into the equivalent machine level language. Keep in mind, a machine understands only ones and zeros. We call it as binary language. So binary language is basically machine language. So you need to convert this high level language to machine level language. In between, we also have an assembly language. So high level language, assembly level language, and machine level language, and then hardware. To communicate with hardware, you need machine level language only, the language of ones and zeros. So keep that in mind. So let us see a small difference between all these things. So the screen gives you a table which has language type, examples, description, and the instruction model. I classified two parts: high level language, low level language. The examples are C, C++, Python, Java, etc. And the description says generally a high level language instruction is written mostly in commonly used language, generally English, right? And you say gross salary is DA plus HRA plus basic salary plus TA, right? So you write the instructions in regular common man language. Hence we call it as a high level language. Now coming to low level language again has two parts: assembly language and machine level language. In assembly level language, we write instructions in structured formats called as mnemonics. In assembly level language, we write instructions in structured formats called as mnemonics. So we write add 24H, STA 2050. So these are standard mnemonics defined for a processor. And then we have low level language. In low level language, we write the instructions in ones and zeros, that is called as binary codes. So as a machine understands only ones and zeros, machine level language has instructions in ones and zeros only. So you write the instruction as 010011001010 and so on, which is a little complex. Fine. So this is how we differentiate high level language from low level language. So going ahead, now we have learned the word language translator. As I told you a minute ago, saying that we have high level language on the top layer and we have machine level and the down layer or the below layer, and you need to convert this high level language to this low level language. Now who will do it? Who will convert this high level language to the low level language? And we have a concept called as language translator. So what is a language translator? It is a system software that translates high level language or an assembly level language to machine level language or vice versa. So you have two categories: high level to machine level and vice versa, and you also have assembly level to low level and vice versa, machine level. So high level to machine level is done by compiler or interpreter, and assembly level to machine level or vice versa is done by assembler. So compilers, interpreters perform the task of translating high level to machine level or vice versa, and assemblers take care of converting assembly language codes to machine codes and vice versa. So language translator is not a device, it is basically a system software. Keep that in mind. So going ahead, let us say difference between compiler and interpreter. So generally this is normally asked in many interviews also. So with respect to input, the compiler takes the complete program into account and it translates all the program at once, whereas an interpreter takes only a particular line of the program and performs conversion line by line. So keep in mind, a compiler converts a complete program as a single block at once, whereas an interpreter converts line by line. Now coming to the output, a compiler generally generates an object code, whereas an interpreter does not generate an object code, it generates an EX file directly. So we'll see what is object code in detail, but for this minute keep in mind that a compiler generates an intermediate code, whereas an interpreter does not generate an intermediate code or intermediate file. Find that. So coming to speed, compilers are faster when compared to interpreters, because compilers take the code as a whole, whereas interpreters take a line as a whole. Now coming to memory, compilers requires larger memory because they take larger chunks of blocks, whereas interpreters requires less memory. The examples where we use compilers are mostly in C, C++, C hash. And we use interpreters in languages like Python, PHP, Perl. These are basically scripting languages. Fine with that? This is the end of the basic terminology. So put your thoughts in the comment section and I'll be ready to share my thoughts. And don't forget to like, share and subscribe. Stay tuned for more videos. Thank you.